Well, the next few labs in OSPF are going to use different layout, and this is the layout. So the first thing I did obviously is to create a proper configuration on the router switches to be able to ping point to point. Then I enabled OSPF everywhere and used Tickle script to verify connectivity. Tickle script I'm using is right here, so it's for each address. Address here is a variable, and in curly braces I put all IP addresses from the boxes, and then I ping all those addresses using that variable. Now, do those addresses, the easiest probably way to get those is by using show alias command. Show IP alias command is gonna show me addresses. Now I press Control in my terminal and I can highlight the whole column and put this into the script. Now let's get to the point. So what I'm going to do now is just explain the difference between the external type 2 prefixes and external type 1 prefixes. There's one small difference, but it can make quite an impact depending on the topology. So what I'm going to do right now is to introduce this EIGRP bunch of 4 prefixes, in fact, or 5, including that network connecting those routers into OSPF world. And obviously for that router to reach the OSPF back, it needs to know OSPF world. So this time around on R6, I need to do redistribution of EIGRP into OSPF and OSPF into EIGRP. So let's go ahead and do that. On the Internet 3, these are the interfaces. So if I do show IP interface brief, I need to run this on interface connecting R6 so we can become neighbors and exchange information. And I need to run EIGRP on those loopbacks, 4 loopbacks that emulates 4 subnets in my topology. So conft and the router EIGRP autonomous system 100. The autonomous system number must match between neighbors in EIGRP. Network 103000. So all these have in common is here, right here, 1030. And so matching wildcard mask will be 0. Match on 10, match on 30, ignore the remaining 2 bytes. So this will ensure that EIGRP is running on all 4 loopbacks. Verification, do show IP EIGRP interface is my command. And I'm running this. I also have to run this on the interface connecting R6, which is this interface. So this is the address. I need to also enable EIGRP on that one. So I'm going to say here network, paste this address and match exactly on it. So do show IP EIGRP interface. I am running also on the interface connecting R6. So now quick jump to R6, conft router EIGRP 100 and do show me IP interface brief exclude unassigned interfaces. So that is going to be network 10.136. All zeros, so quickly I'm going to have an adjacency built between those. Do show IP EIGRP neighbor. I have a neighbor, so I'm probably by now learning. Do show IP route EIGRP. I'm learning those. So now I'm going to introduce into EIGRP. I'm still in the router EIGRP here. I'm going to introduce into this cloud here, EIGRP, the OSPF world. How do I do that? So as of this moment, so if I do show IP route EIGRP on in 3, it doesn't show me anything because the directly connected network is never showing in the table as EIGRP because of the administrative distance lower, the lowest of them all. But if I do a redistribution right now, so what I'm going to jump back on 6, I'm going to say redistributes everything from OSPF process 1. And EIGRP requires a initial or seed metric. If one is not provided, it will assume that all these networks are inaccessible. It uses 5 parameters. So if I say a metric, there's a parameter such as bandwidth. I'll put any number here because it's irrelevant. There's only one gateway anyways. So delay and reliability and loading and MTU, doesn't matter really. Could be all ones in this particular situation. But by now, we're learning external prefixes from OSPF in EIGRP domain. So now we know how to reach OSPF network, and we need to do the opposite, because as of this moment, let's say R1, R2 have no clue. So show IP route OSPF include E2. There's nothing learned from external world. So I'm going back to R6 and I'm going to router OSPF1 redistribute everything from EIGRP Autonomous System 100 and make sure you include the subnets. Don't do automatic summarization to the class boundary. So if I do this again on R1 shortly, we should be receiving those prefixes, and we are. Now, by default, the redistribution introduces the LSA type 5 as external type 2. The metric is type 2. What it means that irrespective of the location of those prefixes inside the OSPF domain, the cost is always the same, 20. So 20 is a default cost that is introduced and doesn't get incremented as the advertisements are exchanged with further and further routers in OSPF domain. They're always going to be 20. So for example, R1 has metric towards the destination metric 20. If I go to int1, let's just see int1, show IP route OSPF include E type 2, it's also 20, even though it's further away from that EIGRP world. In my topology, it doesn't make any difference, so it can stay like that. But if your topology has a different paths of different costs, that may actually make a difference in terms of calculation how to reach this EIGRP world. In that situation, what's recommended, not in my particular situation, but in situation where it does matter, what we can do is change that metric during the redistribution. So I'm going to say redistribute everything from EIGRP 100 subnets, metric type, and there's two choices. The default is 2, where the metric does not get incremented as it is advertised across the network in OSPF, or metric type 1, where it actually going to be different. So R1 now has a different metric than int1. Let's verify that real quick. So jumping to R2, so R1 we checked previously, but now it's E type 1, so I need to change this to include E type 1. And the cost is 40, so it gets incremented as it is advertised further away from that. So R5 has a different metric, so if I do show IP route, it should be closer, include E type 1, it's 30, R2, show IP route OSPF include E type 1, it's 30 versus R1 or int1. R1 has now 40 and int1 should be even further apart away from that. It's 50. So the metric actually does get incremented as the advertisements are exchanged in OSPF domain. So if your topology has a different paths, it may actually makes sense to use E type 1 rather than E type 2, but the default is E type 2.